y'all. This is Aerospace. If you can hear me over the music, today will be a Firefly launch. Thank whoever joins the stream. Thank you for the amazing support. I'm really happy that y'all done that. This means a lot to me. Let's focus on Alpha. I don't know that much about Firefly, but I can just calm the music down. So yeah, it will sound like it's like really loud for me, but for y'all, it's just like a little like speck. Anyways, Firefly will be launching Fly the Lightning, made by Lockheed Martin. That's all I know. You should get mission details from Firefly in 1 minute and 45 seconds. Enjoy the music. It's going to be a daylight launch, so this will be the first daylight launch in 2 years for Firefly. So you'll get a good view of the left side. Of the company, I don't know what's going on.
Release system is armed.
Vehicle has transitioned to autonomous mode. We are go for launch. 3, 2, 1.
Yeah! Woo! It's orange! Go Firefly!
Ascent operations will continue on CD1.
T plus 1 minute. Max Q.
Rico. Stage separation.
Bearing separation confirmed.
Go Firefly. Go Firefly.
Good morning, y'all.
Oh!
We are standing by for
Yo!
Wait a second. Can we get some rocket views on the stream? Do we have any views of a rocket here, please? Stand by, folks. Let's check some rocket views if we could. There we go. Now we've got ourselves a rocket show. Folks, you've joined the official live stream for Firefly Aerospace. It's Flight 4, Fly the Lightning this morning. We are doing a dedicated commercial launch for Lockheed Martin, and really quickly, NASA Spaceflight is providing live stream services for Firefly Aerospace for today's stream. I'm John Galloway with NSF. With me today this morning, I've got a friend who knows a lot more about rockets than me, Miles Gray. Dr. Miles Gray, how you doing?
I'm doing pretty well. How are you?
I'm pretty good. How did we luck out and get you on the stream this morning? You're busy with the rocket.
Yeah, so I'm the chief engineer for our other rocket, MLV.
MLV.
And so I'm not working on Alpha anymore, but I came to Firefly 5 years ago and worked a lot on Alpha, so I have kind of a lot of information about Alpha, but I'm not critical for the launch today.
Gotcha. So you're not on console and mission control, so you get to hang out with us?
Yeah, exactly.
All right. So Miles will be providing us some information about Alpha because he's worked on it himself. And we are coming up now less than an hour for launch. Appreciate everybody joining us today. You may be watching in multiple different places. You may be over on Firefly's official YouTube channel. If you are, make sure you follow along there. Ring the bell or whatever you're supposed to do. You may also be watching it on NSF stream. You may be watching it on social media X as well. Wherever you're watching, thank you so much for joining us. This morning, we have just a 16-minute window remaining, I think, right? I think we were down to 16 minutes starting at, where was our T0? We're talking about Vandenberg here. All right. I believe our T0 is coming up in less than an hour, coming up on 56 minutes now. There we go. And we're looking at Slick 2 over here at Vandenberg. There's the zoom in coming down the coast. Anything informational about here at Slick 2?
So Slick 2, it's our pad. We're kind of near the beach, a little bit more inland than some of the other pads. Just down the way is Shark Beach.
Shark Beach. Are there actually sharks there?
There is a bunch of sharks there. It is the largest breeding and feeding site for great whites.
Largest breeding and breeding site for great whites.
Not a lot of swimming.
Not a lot of swimming there. So more focusing on the rocket, working on the rocket than going down and hanging out at the beach.
Yes.
All right. Hey, folks, some other housekeeping real quick. Today, at the request of the customer, we are going to remove the live views of the vehicle after SECO 1. So we'll tell you a little bit more about SECO 1 and the mission operations that are going to happen. But intentionally, those feeds will be cut after SECO 1. It's got a long coast phase in there. We're not going to stay around for the entire coast phase. Just want y'all to know if we turn off those feeds, that is an intentional thing. So we got past the Shark Beach part, I guess. Since we're doing the live stream here, also, if you've got questions for us, you can tag us in chat on whatever channel you're watching at Firefly Space if you're on Firefly's YouTube channel, and at NASA Spaceflight if you're on NASA Spaceflight's YouTube channel. So we've been going a little while here, and the teams have already been working on the rocket this morning, haven't they?
That's right. You can see on the camera there's not actually anybody out there now because we already went through pad clear. That happened at T minus 4 hours and 30 minutes. So everybody's gone. That group is called Red Team. They their whole job is pulling off the RBF tags. They're turning the last valves they need to get propellant on board. They're basically just kind of locking up as they retreat from the pad.
Gotcha.
So that happened at 4 hours and 30 minutes. We started the rocket comes alive. From my perspective, at least, I'm kind of a fluids guy, but
it starts to breathe.
Yeah, it starts to breathe at T minus 6 hours. We start loading helium. So our system has a circulation loop rather than just filling helium into the LOX tanks.
Right.
So we start at T minus 6 hours. We start chilling and filling. So we're increasing pressure as we're going down in temperature. And then an hour later, we started fuel load. So we can put fuel on when people are still out there. We just can't put up fuel and oxidizer.
At the same time.
Yeah, you can't allow those to, because it's risky if they mix. And
right. That's sort of how the rocket works in the first place.
Exactly.
Yeah.
So we loaded basically all the fuel at T minus 5 hours. So it's completely full of fuel. And then immediately after pad clear, we can start loading LOX. So we also have almost all of the LOX on board that we're going to have.
Gotcha.
You can actually see on the stream there, there's this kind of plume of gas that's coming out. That is the first stage from this view. That's the first stage LOX tank. It's just boiling off. So we fill saturated LOX as opposed to subcooled LOX. So
right.
Some rocket companies will fill. They pre-chill the LOX, so it's actually colder than its boiling point. So the whole time it's on the pad, it's slowly warming up.
Right.
We do the opposite. We actually fill. It's above its boiling point, and it's slowly boiling down. It's getting colder and colder as it boils.
Wait, it gets colder as it boils?
Yeah, thermodynamics.
Thermodynamics. Outside the scope of this stream,
Yes.
we'll need like a 2-hour stream to explain thermodynamics.
The magic of thermodynamics. It's getting colder the whole time. That also means that it's boiling off, so it's losing mass. So that fog that you're seeing is it just barfing out mass the whole time.
Barfing out mass. We brought the rocket science onto the stream here, folks, this morning. But it's intentional is the important thing.
Yeah, that's it. And you can see there should be, it's a little hard to see in this, but there's actually 2 more plumes above that. That's the second stage. So the first stage is just one big one, and then there's 2 that are on opposite sides for the second stage.
Gotcha.
So that it's non-propulsive.
Non-propulsive. That would be a problem if you have venting coming out one side of the rocket and it's trying to coast. That may impart some
Exactly. So you
impulse
have
onto
to
the
be
rocket.
constantly correcting in your coast period, and you don't want to do that. You're just using RCS gas. You
Don't want to do that. All right, good deal. Let's see here. Folks, a quick correction, or not a correction, on the T0 here. The T0 is actually set for 9:32 and 30 seconds this morning, about 52 and a half minutes, 51 minutes away right now. We had a late-breaking change in the T0, so I was ready to tell you at the very beginning and wanted to make sure I said the right thing. Where are we coming up next? We've got some payload, I think, information here. Here we go. Yeah, so this payload is actually delivering faster on-orbit capabilities for U.S. warfighters. Remember, it's a commercial payload for Lockheed Martin. It's a national security technology demonstration. What does that mean? Oh, we've got some information about it, right?
We do.
We have a little bit of information put out on social media. You may have seen that we're talking about electronically steerable antennas, I think, right?
Exactly.
The electronically steerable. You know something? The best people to tell us about the payload are the people who built it. So let's get some information directly from Lockheed Martin here, if we could.
Hi, I'm Paul Pelly, Senior Director of Global Security at Lockheed Martin Space. I'm excited for today's Firefly launch, Hi, I'm Paul Pelly, Senior Director of Global Security at Lockheed Martin Space. I'm excited for today's Firefly launch, and I want to share a little context about the unique payload we're launching into orbit. It really is all about responding to our customers' need for increased speed to mission. Historically, on-orbit sensors can take months to be fully calibrated and ready to perform their missions after initial power on. Using the innovation of Lockheed Martin's Ignite team, we've self-funded and developed a unique wideband electronically steerable antenna, or ESA, for this demonstration. Our ESA is a novel scalable design using highly reliable commercial parts and is mass producible. Once we're on orbit and our satellite has completed checkout, Lockheed Martin expects to calibrate this new ESA sensor in a fraction of the time it takes to operationalize traditional on-orbit sensors. Essentially, we're going to show how we can put on-orbit capability into the hands of our warfighters faster. This demonstration is an example of Lockheed Martin's significant investment in bringing scalable ESA technology to orbit. ESAs are powerful and incredibly flexible, have no moving parts, and can generate multiple energy beams simultaneously. We believe this technology is critical to future remote sensing architectures. Lockheed Martin is excited to show what this ESA can do on orbit. Go for launch.
Well, there you go, ESA. Interesting acronym there. The actual electronically steerable antenna. And it's not just the antenna that they're testing here today. It's actually launching on a Terran Orbital Nebula satellite bus. So a lot of different companies, organizations coming together for the mission today. Y'all are providing the launch services. We've got a satellite bus provider. We've got the client, Lockheed Martin, with the antenna. We've got the range that helps us out as well. Lots of different teams that need to come together for this to happen.
It's a party.
It's a regular party. Nice. So how does this actually happen? We're talking about responsive space operations here, right? Let's talk a little bit about what that actually means.
That's right. So, and we had a weather scrub 2 days ago. So
right.
it's not worked exactly the same today as it did would normally work in terms of that launching paradigm. But basically, what that means is that we're launching payloads. We're encapsulating payloads and getting them out to the pad and launching all in a very accelerated timescale. So
right.
Around 24 hours. You compare that to something like the old way of doing this, which would be, you get a payload, maybe 6 months ahead of time.
Yeah, months or weeks.
You're processing it for weeks and weeks and weeks, and then finally you have it out on the pad. It's on the pad for a while. Eventually it goes up and it launches.
Right, so less than 24 hours. Even
Right.
with the weather scrub, like we're basically using the next available attempt here, I guess, right?
And so like on two days ago, we were on perfect track to hit, I think, 20 hours actually.
There's a
instead of
little
24.
sliver there. There's normally months or weeks, and there's the Firefly less than 24 hours. That's actually around 19 hours, I think, here. But a little different today, like you said, because we had the weather scrub, payload was encapsulated, it was integrated on top of the rocket, so that part was already ready.
Exactly.
And teams have been counting down today, doing the other final payload closeouts, the transport and mate to fairing. That was already done, and we've been in launch ops here, haven't we?
Right. And so, I can go into this in a lot of detail, but it's probably better to listen to people that are really experts in this.
We've got some time here, I think.
Oh, we do? Okay.
Yeah, to talk a little bit about it.
Okay,
Let's
well,
see here.
basically the way this works is that the fairing is in another building. It's called the Payload Processing Facility.
Probably the PPF.
PPF,
Yeah.
yep.
I worked it out myself.
Fairing and the payload are off the pad. They're
Right.
in another building. It's pretty nearby, but it's not on the pad.
Not just not on the rocket, but not even at the pad. It's
Right.
just a little ways away.
Right. And
Right.
so a day ahead of time or so, we encapsulate that payload.
Let's actually put it into the fairing.
Right. So we stick it on. There's a whole segment here. There's something called the PAF, the payload attachment fitting, that is right below those fairings. So you attach it to that, encapsulate with the fairings. The fairings are that kind of silver section at the very top of the rocket.
It's a little bit wider.
Yeah, bigger diameter.
Yeah.
So that whole thing is encapsulated. It's horizontal, and it rolls over to the pad under air conditioning. You can see it's fairly wet out, so we have to be really thoughtful about making sure that that payload doesn't get wet, because
You don't want rain on your satellites.
yeah, water on satellites is like, no, not allowed.
Not a lot of water in space.
Yeah, so we can't allow any water to get on the satellite. So there's a very specific humidity range that we're allowed to be in. We also can't get too dry, because
Right.
then you start risking like arcing and stuff like that.
Gotcha. So you control the environment that the satellite's in.
Yes, so we have this little portable air conditioner that carts along next to the payload fairing. It rolls out to the pad. The rocket is on the pad on the strong back. It's
Right.
already mated and everything. And then we raise that payload fairing and stick it onto the end of the rocket. And then it's ready to go.
Gotcha. You made a little hand motion, like you did this number.
Yes.
Is it actually a cart that somebody's pushing?
It
or-
is. I think it actually is a cart right now.
Well, I saw them
'cause
raise the
move
payload
We
up.
move pretty slow, and then the payload fairing itself is, there's a bunch of people out there. It's a
I saw cranking operations to raise the payload.
There's some cranking involved.
I think there might be a pickup truck towing things around
there's
too.
some people that are stronger in certain ways than they otherwise would be.
Because we're like, go for cranking operations.
Yeah.
Anyways, so all of that has been done, not just today in the last 24 hours, but in the nominal flow for the responsive space operations. It's 24 hours to not only put the payload in the fairing, get the fairing over to the rocket, integrate the fairing on top of the rocket, verticate the rocket. There's our verticate.
Verticate the rocket,
It's totally
and then,
real word.
And then get everything ready to run through the 3,000 steps to get the rocket ready to go.
Good deal. And we've got a little video to show you all some of the behind the scenes of this actually happening with some Fireflies explaining it to us. You know these folks, don't you?
Adam, Jordy, and Megan are all good friends of mine. They're going to explain this way better than I can.
All right, let's roll the video and see what happens with getting the payload on the rocket.
So Victus Nox was a responsive space mission that wanted us to demonstrate the time from when you actually put the payload to when you put the payload and then put that payload in orbit. So we received a phone call basically at 4 p.m. and then ended up launching at basically 7:30 the next day. That had us encapsulating the payload, driving it out to the pad, putting the payload onto the vehicle, and then rotating up, and then
Firefly's gonna be like,
taking off from there and put the payload
can't do
actually
that.
into the target orbit right where we want it to be.
payload deployment.
And the beauty was the excitement, right? That we had, that there was ownership, that had that ownership for the system, that's saying, we're not giving up, right? And up to the day of, it's like, it's getting tight, we can't do it. It's like, no, how can we do it?
Ultimately, the team was able to work through those. So getting the payload out there a little later than planned, hitting a few other bumps in the road, and then rotating up and launching. And what is the record time for us? That for what we look to do, it's not always it's not demonstrating the best ever. It's, are we getting incrementally better every time?
And the amazing thing was that we hit our first window on the first day, on the first minute that we attempted.
So responsive space as a whole is really kind of just taking the things that the business, I'll say the industry has let become stagnant. That there's a concept that you have to have all these checkouts and all of this stuff that happens before you encapsulate and lift off. And for extreme high value satellites, that not only makes sense, but now the industry is lopsided where the satellites have come down in price and the launch prices have basically stayed the same, to where it all comes down to how fast you can do that last bit to give your customer a white glove service to space.
Victus was a challenge, but we're trying to make it now as the new norm, right? Because then obviously the Department of Defense is going to be really excited that we can protect the United States for any threat immediately in 24 hours. But also there's customers that are going to say like, hey, rather than having my payload in space, orbiting in case one breaks, I'm going to have it on the ground. And if something breaks, rather than having it there for 2 years, I'll just go replace it in 24 hours. Right, so I think it's something that the space industry had to get there, and we were the first ones to do that. I'm sure there's going to be others that will be, but I think it should be the new norm for space. Like rapid response, we need to be able to respond for any threat, any need to get up to space.
So responsive space operations. I haven't heard a lot of talk about that, but it's about getting payloads into space on, I guess, short notice.
Yeah.
Yeah. What different people can use that? Like, why would we need to get a satellite into space on short notice?
I mean, there's a bunch of reasons for that. I mean, you can kind of think anything that any benefit you'd get from satellites, space, anything, right? If that is more of a benefit in a sort of an event situation that you can't predict, then that's really good for you. So if there's an earthquake or there's a conflict or whatever, something that happens that you weren't expecting and you need to know information about that immediately, it becomes really valuable. Like
replacing a commercial satellite. Like say you have a network of satellites up and one of them has a failure, a problem. How do you replace that? Well, why don't you just leave them all up in space? You designed that satellite 5 years ago, 7 years ago. You launched it 3, 4, 5 years ago. Technology's come a little way since then. So why not have your most recent technology in the hangar on the barn and then send it to space when you need it, if you can get it done in less than 24 hours? We've heard about airline-like operations for rockets, for space, right? And when I book airline tickets, I don't book them 6 months in advance. I don't book them 2 years in advance like rockets have to book their trips right now, right? Like payloads have to book their trips. I book my ticket to come out here the day before I needed to be here, and that's sort of how responsive space operations work.
Exactly. It's much quicker.
It's much quicker. All right. So coming up next, we're going to talk a little bit about something that's near and dear to your interests, the Alpha rocket itself.
Yeah. Alpha's a two-stage rocket. You can kind of see on the frame there that the first stage is basically everything below that first lower line of the ice.
Yeah, there we go. With the logo on it, the Firefly.
Yep. So that ice is where the LOX tank is. So it's like maybe 80% of the rocket itself is the first stage.
Right.
So that does most of the heavy lifting. And then the second stage is that little segment in between the silver fairing and the first stage.
Gotcha.
So it's much smaller. It actually does most of the change in velocity, but it's doing most of that sideways rather than up. So the first stage is kind of getting us up, and then second
out
stage
of the atmosphere, get a little altitude.
Right. So Alpha carries about 1,000 kilograms to low Earth orbit. So that puts us in kind of we're the largest of the small launchers.
So it's the largest of the small launchers. So a smaller payload. I mean, 1,000 kilograms is a small
it's like
payload.
we're putting up like a dishwasher.
Couple like a refrigerator or something.
Yeah. Yes.
Nice.
Big little guy. So that first stage is run off of 4 Reaver engines.
Right.
The second stage is a single Lightning engine. Those are all designed, built, tested in-house. They're both tap-off cycle engines. So,
okay, tap-off cycle.
Yep, tap-off cycle. So when we talk about a cycle of an engine, what we're talking about is how the turbopump is being spun.
It's how the engine is providing power, or I guess flow, for itself, right?
Yes, exactly. So
use
in a tap-off cycle
preburner.
engine, you're taking there's the combustion chamber where all the propellant is exploding continuously.
Right. In a very controlled manner.
In a very controlled manner, and it's you run that through to the turbine, and that spins the pump.
Right.
And the pump then puts more propellant into the chamber for that to then combust and keep that process going.
Right. So tap-off cycle. Latest, greatest technology. You trying to break any records, or why'd you choose that one?
No, tap-off cycle's actually been around for like 50 years. The sort of the follow-on actually to the Saturn V second stage was going to be a tap-off engine.
Right.
But never flew. The So that
let's see here. So we were talking about the tap-off cycle. We're not trying to break any records with the tap-off cycle or anything like that.
It's a very simple cycle. So
Right.
there's not very many parts to this. Normally, with an open cycle engine, that would be similar performance.
Right.
You have to have what's called a gas generator, which is like a tiny little rocket engine, which
Sure.
is hard to make. So we have fewer parts. It's easier to produce. It's a little bit more complicated to get it started.
Yeah.
To figure out how to bootstrap that start.
Gotcha.
But
You're going for reliability. You want something that's simple,
Exactly.
fewer parts, easier to manufacture,
fewer
nice
parts
and reliable.
means fewer things to break. So we're into tap off.
Gotcha. Good deal. We had a quick question from the audience, actually. We said it's about 1,000 kilograms. What's the max? Is that the maximum payload? Because it says 1,000 plus.
Well, so it's a little hard to say one number there, right? Because the any different orbit, there's a lot of LEO orbits, for
Right.
instance. So if we went really low, we could get something like maybe as much as 1,400. But if we're going to something that's more useful, it's more in the range of 1,000 kilograms.
Gotcha. It just depends on where you're going.
Yeah, and you can go higher, you can go lower. It really depends. Also, the launch site, there's a lot that goes into that.
Gotcha. Now, there's some other things we haven't talked about. The main body of the rocket is carbon fiber composites all the way down. But we have a video here that's going to give you some more details about how y'all actually test this. I mean, you know the details. We're going to show the viewers the details if we're ready to roll that fly like you test approach. Pretty sure it's coming up here.
No sound.
Anything that happens at the pad, we do here in Briggs. So a test campaign for the Alpha Stage, we really have Alpha Stage 1 and Alpha Stage 2 as the major items being tested. All those other individual components kind of get tested, brought together in the integrated stage. So that first stage goes onto the stand, we'll light the engines up and do roughly a 40-second burn on those engines. And we want to prove out all the profiles, make sure the tanks are pressing right, make sure those engines are performing properly, but at the same time kind of restricting that back so we're not putting extra wear and tear on that hardware that we need to fly. There's also a second stage test campaign where we will take the second stage and put it out on the test stand. When we're doing that testing, it gets pretty interesting because we want to simulate everything like we do in flight. So one of the things that we'll do is actually simulate the first stage burn during that flight. So you'll see T0 and you have silence. Everything is nice and quiet where you normally hear it rumbling. It actually goes all the way through the first stage burn and simulating the tank presses, vent rates, everything, and then stage step simulates and we get into that second stage burn where we'll typically do, once again, a 40 to 60 second hot fire on that second stage. So there's a few really large benefits of having everything here at the Briggs site. The first thing I would say is that our machine shop is right here on site. There are many times where something doesn't work according to plan, or there's a little bit of tweak that has to be made, and we can just send a part right over to the machine shop, get that fixed, and have it back out on the test stand that same day to continue through a test. A few other benefits is if we have an issue with a test, or we just need support from one of the engineering groups, those responsible engineers for the components are many times right in the building next door. So if I have a problem, instead of getting on the phone, I'll just walk around and go find that person, talk to them. We like to call it face words, is one of our terms, but really have that conversation right there with that person and get to the bottom of it and get rid of that problem and move on with your day.
I think I'd have a good time if I came over and visited y'all out at Briggs.
You are welcome anytime.
We just set that up. Folks, if you're just joining us, we're now less than 35 minutes away from today's target T0. We have Alpha Flight 4 going off here, commercial payload for Lockheed Martin, and this is, well, I just said Flight 4. I don't have to say that again. Anyways, coming up in 35 minutes, wherever you're watching, make sure you toss a follow over to Firefly. You can make sure you subscribe to the channel, and they're also doing updates on their social media, Firefly, at Firefly_space over on X. So operations are ongoing right now. The pad is clear. We talked about that a little bit earlier, but there's still things happening with the rocket to prepare for launch. A couple minutes ago, I think we were talking about stage 2. What are we looking at?
Yeah, so about 10 minutes ago now, the second stage LOX tank started being topped off. So basically we boiled down, we lost some mass. And now we've set up just a trickle of locks into that to keep that at the flight level.
So it was like pre-filled, and then it emptied out a little bit, and then you
and now
started
we're just
topping it back.
keeping it just still at some specific level. Anything that boils off, we add back in.
You have like a cool acronym for that, or it's just called topping off?
It's just called top off.
It's just top off.
And so at second stage, you can probably see that a little bit in that plume in the top. If you've been paying really close attention, it got a little bit stronger.
A little stronger,
10 minutes ago. That's also, it's convenient for us. This is not, because of the tank construction, these are it's really easy to get, very predictable temperatures in this. So,
because of the carbon composites.
Yes, exactly. They're basically this acts like a thermos. It's pretty unique construction. It's super lightweight.
Is it two walls like a thermos? Like
it is two walls.
Sandwich
it's called a sandwich panel.
A sandwich panel.
There's other composite rockets out there, which is kind of the way things are going in terms of, because composites are just so lightweight.
Right.
But this construction is, I think, unique in the industry.
Yeah. Is it so you get a lot of benefits out of that? I mean, it's super lightweight, so you have more mass of the rocket that is not rocket.
Yes,
or I guess
exactly.
you have less mass of the rocket that is rocket.
Any of that mass that was rocket can now be payload.
Can now be payload instead of rocket.
Right.
Nice. So you're able to build those tanks. They not only let you have a very lightweight body, main structure of the rocket, but also they get you to very predictable temperatures, like controllable environment inside the tanks.
Exactly.
You're so much affected by the outside environment with your temperatures.
Yeah, and you can see there's ice on the tanks right now, but that's not always happening. It's because it's really wet out. If we were in like Texas doing stage tests, there's not even any ice outside. So
right.
It's pretty. That is unique in rocket world.
Gotcha. And just a couple minutes ago, I think we had a water test that may have happened.
Yeah, so we did just a test of the deluge system.
Right.
So on the pad, there's a lot of fire coming out of the bottom of the rocket, and so there are, you want to suppress any of those fires, and so we have all this water that's coming out of the pad.
Right.
And it seems like that's going to be there for fires, and really what it's there for is actually sound.
Like dealing with the sound energy.
Dealing with the sound, yeah. You can imagine as the rocket leaves the pad, that plume that's coming out of the bottom of the rocket is just creating a wall of sound.
Right.
It's if you don't have that deluge, it'll hit the ground, bounce back up, and just rattle the rocket apart.
Shake the rocket. It's reflecting off the pad and shaking the rocket.
Yeah, which would mean that you'd have to qualify everything in the rocket to just this ridiculous noise level that it would be very hard.
Right.
So what we do instead is we just flood the pad with water. There's droplets everywhere. The speed of sound in water is different.
Yep.
So as that wall of sound hits that, it decoheres. It goes in all different directions. And then whatever gets back up, it also loses energy in the water.
Yep.
Whatever gets back up to the rocket is way lower energy and just doesn't
effectively mitigated. Whatever reaches the rocket is
mitigated. We're kind of pulling like a curtain in front of the rocket as it leaves the ground.
And it's not just about, it's not a solid body of water. The water is sort of in droplet format. It's spread out, and so there's tons, think about it, there's tons of interfaces. It goes from air to a water droplet to air to a water droplet, and every time it's going through that interface, I guess you could say, it's changing the direction, it's dealing with some of the energy, it's making sure the sound isn't shaking the rocket to pieces as it goes off the pad.
Exactly.
All right. And then coming up here, where are we? 30 seconds from T-minus 30 minutes. What's going to happen at T-minus 30 minutes?
We should be able to see this on the stream. The second stage engine is going to start pre-chilling. So there's two, again, same way as the vent up there for the tank. There's two outlets that are coming out of the kind of the lower part of the second stage.
Right.
What we're doing there is we're pulling LOX, liquid oxygen, through the engine, and we're chilling in the LOX pump. So if you don't have your pump really cold when you try to start your engine,
right.
When it starts to spin, instead of pulling LOX through it,
liquid LOX.
Instead of pulling that liquid through it will just flash that into gas, and it'll just sit there spinning.
It's like cavitate?
It's cavitating.
It literally cavitates. So when we talk about engine pre-chill, we're chilling the engine down to a proper operating temperature, so you're not surprising it or trying to get it to operate in a temperature it's not supposed to be.
Yeah, exactly. A lot of the sort of secret sauce of rocket engine operation is that you just make sure that always the conditions that the engine is getting are exactly what you thought you were going to get. So then you can test it and make sure it's going to work.
Gotcha. All right. And again, folks, we may be able to see a little bit of that. Again, the venting that you see on the screen and stuff like that, that's all intentional. Loxygen. I'm not supposed to say. It's LOX.
Loxygen.
Liquid oxygen or LOX is boiling off. You're maintaining those pressures. You're purging things. All these are nominal things that we're seeing on the screen right here now. So we are continuing to stand by for the flight. It's Flight 4 of Alpha Rocket, Firefly's Alpha Rocket here. Just got a little bit of a range weather update in my ear, and they just told me that the range is green, or the weather is green currently.
Yeah. So we on 2 days ago, we scrubbed for weather. That was a compounding set of factors. About the worst weather you can have in Vandenberg.
Yep. I was surprised. I was told it was beautiful in California, and I show up and I'm like, it's raining. What's happening?
we had both very thick cloud cover. We had lightning coming towards the pad,
right?
And we had high upper level winds. So it was just like boom, boom, boom. Everything is terrible. We still fought through a ton of that, and in fact, also the weather was terrible the next day as well. So we were fighting through that for operations on the ground, just getting ready for today.
Even we were out there dealing with cameras, and we were getting poured on Thursday there. So, folks, remember, we've talked about a couple different things. Weather is currently green, it sounds like. How do we get the weather for the launch pad? We don't just go to our weather app on our phone and say, what are the upper level winds? It's actually Vandenberg Space Launch Delta 30 that supports the West Coast launch activities here for Department of Defense and NASA and commercial missions like this one here. They've been doing a ton of work to enable these responsive space missions. We've got a little bit of information here from Colonel Mark Shoemaker, who is the commander of Vandenberg Space Force Base. So let's go ahead and listen into what he has to say.
This is a special time of year for Guardians and Airmen at Vandenberg Space Force Base. We're celebrating the 4th anniversary of the United States Space Force, and with that, celebrating our Guardians and Airmen who make all of our installations missions happen each day. In the last 4 years, we have witnessed remarkable growth and transformation at Vandenberg as an agile power projection platform for space operations. If you've had the privilege of visiting our amazing base or being a part of our mission, you've had the unique opportunity to witness high-level, critically important national security missions unfold on the backdrop of our pristine coastline. More than 2,000 missions have launched off of our 118,000-acre base since 1958, a testament to the commitment of our Guardians and Airmen in advancing space and strategic deterrent capabilities. We're not stopping there. What was once a monthly launch cadence has become closer to a weekly event, a significant evolution that underscores our dedication to the rapid response needs of space operations. The next 2,000 launches will likely happen in less than half the time it took for the first 2,000. And to meet that demand signal, we're growing our capacity, our agility, our resilience, and responsiveness to meet the nation's needs head-on and surpass all expectations. And it's that last quality of responsiveness that I want to talk more about today. Space capabilities empower the world, our nation, and our entire joint force. And our commercial partners deliver many of these capabilities, playing a vital role in achieving our nation's strategic objectives in space. And so it's vital that we responsibly support our spaceport partners to assure resilient U.S. Space Force spaceport capabilities to launch and deploy national security missions on short notice. We take great pride in our U.S. Space Force in the to-space part of the mission, and we must continue to be more responsive, remove obstacles at every opportunity, shift launches earlier, approve launch attempts on very short notice, as we demonstrated in support of our U.S. Space Force Victus Nox launch on September 14th this year. And all of this is to enable simultaneous launch operations and countdowns, delivering the spaceport of the future that the nation needs. It's my pleasure to lead the Space Launch Delta 30 team who makes launches from Vandenberg possible. We will continue to foster a culture of innovation and collaboration, pushing the boundaries of what is possible, advancing space capabilities through strong partnerships, and securing the future of space operations together.
You know, I talk about this a lot. It's not just the launch provider. It's not just the payload customer. There's so many different teams, including the Space Force Delta 30 out here at Vandenberg, that support these launch operations. It's always good to see what goes on, especially as we get into these higher cadences. We have a lot more rockets to launch and how they support that mission. We had another question from the audience come through here, actually. I don't know the answer to this. We talked about there's some ice forming on the outside of the rocket as the atmosphere sort of freezes on the outside. Does Firefly have to account or calculate that when launching?
We kind of did an early calculation just looking at it the first time we got out here, because in Texas we basically didn't have any ice. We got out here and there was a brief worry, but if you are able to go out there and touch that ice is it's very, very thin. It's like a thin dusting of snow.
Don't do that, by the way.
Don't do that. So that it's not very much to begin with. But then the other part is that in the launch, there's a lot of aero heating on the outside. So as you're going so fast that the air just gets hot.
It warms up.
Yeah, it's frictional heating with the vehicle. So the rocket is hot as it's flying away.
Gotcha.
And almost all of that ice melts away during the first stage burn. And first stage, mass.
Is the bigger stage.
It'll be like mass of the first stage, and so that doesn't contribute as much to payload loss as the second stage mass would. When the second stage is burning, when that would matter, it already has
It's
no
already
ice on
melted
it.
off. It's
Yeah.
like the payload fraction or the mass fraction of the ice.
Yes.
Is low, or it's low because the payload or the booster mass is high when the ice is on there.
Yes.
And it's gone by the time you get to the
That's a
second
good way to
stage.
think about it.
So I sort of stumbled through that, but I hope you all got the point. Coming up, where are we at here? Less than 25 minutes, 23 and a half minutes about here. Coming up before Flight 4's current targeted T0. If you're just joining us, whichever channel you're watching on, make sure you follow along. Firefly hopefully is going to be doing more of this stuff. They're releasing cool videos and all sorts of things so you can get caught up with here. But current operations, or not current operations, let's talk a little bit about what the rocket's going to do when it takes off. It's going to get really busy here in the last 20, 15 minutes. So now while we have some time, what should we expect at T0, T-2?
Yeah, so when we keep on saying T0 today, what that means is actually the point when the mechanism that's holding, the clamps that are holding the rocket to the ground are going to let go. That's T0. That's what we call T0. Different rocket companies do different things. Some of them use the engine start. We use those clamps.
So you light the engines before the clamps release, and
Right.
T0 is when the clamps release.
Yeah, so T-2 seconds, the first stage engines start up. So we put spin gas in, put a bunch of T-Teb. T-Teb is a pyrophoric liquid, so it is a really, really, really flammable thing that when it touches air or oxygen, it just instantly ignites.
Just wants to be on fire.
Yeah, it wants to be on fire dearly. It will
Dearly wants to be on fire.
It will burn water. So we put T-Teb in there, engine start up. We have about maybe a second where we look at the engines and everything on the stage, and it's an automatic check that is going through. Computer looks at everything and says, okay, it's healthy. We let go of the clamps, and then we immediately start accelerating upwards.
We get first motion, and then we'll see a trajectory that looks a little bit like this here. There's that stage 1 ignition, T-2 seconds, liftoff T0,
Right.
and then we go into Mach 1 Max Q. Tell us about those.
Right, so Mach 1, that's when we're supersonic. Max Q is the point where the density is dropping and the velocity is going up, and the combination of those two things means that at some point there's a maximum point where you're like crushing the rocket.
Yeah,
with
the maximum dynamic pressure.
With aerodynamic pressure.
Based on the density of the atmosphere and everything else.
And those are the two most sort of difficult control regimes that the rocket has to pass through. Supersonic, when you pass through the sound barrier, you have to
deal with those forces.
Yes.
Like that's where the forces are. I mean, you go through a little bump when you pass through the
your
sound
control
barrier.
scheme has to change.
Yeah.
So both of those are hard, and then Max Q is just hard because there's a lot of forces.
Yep, and we saw MECO there, main engine cutoff that's going to be happening.
Cut off. The first stage shuts off. The stages separate. Second stage starts up, and then about 15 seconds later, the fairings will pop off. We'll be able to see that in the camera.
Yep.
And then we have 5 minutes of burn time, and then SECO.
All right, so that is what we'll expect after liftoff here. I think in just a couple minutes, we're actually going to come up on a mission control call out. We're going to try to pipe that into y'all, but we don't know exactly when it's going to happen. So if we're in the middle of something or saying something and we need to go to mission control, just expect us to zip up and listen in on the go, no go poll that's coming up here shortly. We're talking about these launches, and we had the main engine cutoff, we had the SECO, but there was a SECO 1 and a SECO 2.
Right. So SECO 1 is the first time the engine shuts off on the second stage, and we've used almost all of our propellant at that point on the second stage. So it's really lightweight.
Right.
And then there is about 45 minutes usually of coast period.
FSW. Go.
Because we've
GSW.
done a
Go. GNC. Go.
Here's the go.
Prop.
Go.
Fluids.
Go.
Structures.
Go.
ABI.
Go.
FTS. Go. GC. Go. VC.
Go.
Payload.
Go.
PMM.
Go.
Elbow.
Go.
FISPO.
Go.
IFCO.
Go.
OSM.
Go.
ROC. Go. MA.
Go.
CE.
Go for terminal count.
LD.
LD is go.
LDA.
LDA clear to launch.
We are go for launch.
That's what we wanted to hear.
That is what we wanted to hear.
That was just straight. That was smooth.
Yep, super smooth. That's great news.
Just straight down the pole. You saw we had a full board
please
of greens there. Flight 4, go for launch. It looks like actually got some I think that's actually back in Texas, that view there.
Yeah, that was Texas.
Everybody's cheering as I saw some hands in the air there. Still have some time. We're under 20 minutes now, folks, but you just heard the go, no-go poll, and looks like everything is currently green as we keep marching towards that T0 that's coming up here. Let's see here. What do we have? Is that like an exciting time? Like, is that like a, oh, it's really happening now?
Yes. The time between saying go and then the rocket leaving the ground is 20 minutes, but it feels like 20 seconds. It's
18 and a half minutes now, actually.
It's very fast.
Time just feels like it evaporates here.
You just become one with the plots, and
all I see is go, 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 go. Like, all right. So, folks, if you're just joining us, you're watching Firefly Aerospace's official broadcast. We're coming up on Flight 4 here. This is an Alpha rocket launching a payload for Lockheed Martin. And in fact, we've actually got a couple words coming up from Lockheed Martin. Let's go ahead and listen in on this to hear what they have to say.
Hi, I'm Robert Lightfoot, Executive Vice President of Lockheed Martin Space. I couldn't join you in person for the launch today, but know I'm watching and I appreciate the opportunity to share a few thoughts about this exciting and historic event. First, I want to thank Firefly Aerospace. Not only are we launching a technology demonstration today, but we're also sharing a strong collaboration between Lockheed Martin and Firefly Aerospace. We appreciate their drive to provide reliable space access, which is critical not only for the entire space industry, but also allows us to test our capabilities with greater urgency to be able to deliver new solutions. In a little while, a Firefly Alpha rocket is scheduled to launch our first self-funded and self-developed payload, critical for proving out new on-orbit capabilities faster than ever before. Developing new systems like these are extremely important to our customers and help to keep our nation and warfighters safe. Today's launch is also important in another way. The space industry is one in which you cannot go it alone. We share a lot of similarities with early entrants like Firefly, and we are proud to work with them and other emerging providers because it takes a variety of innovations, capabilities, and people to ensure we are all successful. Together, we will ensure a resilient launch environment and assure access to space for all important missions. Thank you to the entire team supporting this Fly the Lightning launch. We're looking forward to the ride. Let's go for launch.
Folks, things are going to start happening really quickly here as we are currently 16 minutes and 22 seconds away from the target T0. Now, what's going to happen is we've got one more bit from Firefly, I think, to share some words right before the launch, and then we're going to hop right into that auto sequence and explain what's happening on the rocket. That's why we've got the rocket engineer with rocket scientist, rocket engineer. Either way, let's listen into Firefly Aerospace real quick.
Hey guys, Bill Weber here, CEO of Firefly. We're just about to launch our Alpha rocket, so I'm going to keep this short. I want to give a quick shout out to our incredible team of Fireflies. As we continue through this countdown, I want all of you watching with us to understand what it took to get here today. Our team of Fireflies are the most hardworking and passionate people that you're going to find in this industry. It's their relentless dedication, innovation, and grit that got us to this very moment, and I want to thank them for their incredible commitment to making our customers successful. This Fly the Lightning mission for Lockheed Martin has served as yet another opportunity for our team to continue practicing and advancing our responsive space capabilities. Leading up to the mission, the team further rehearsed our standard launch operations. We focused on improving efficiencies, cutting out unnecessary steps, and moving faster to ready payloads and our rocket for liftoff. Firefly's goal is to ultimately become the go-to responsive space provider for both government and commercial customers. In fact, along with Lockheed Martin, we have members from the Space Force's Tactically Responsive Space Team here with us today observing this mission. Together with our partners, we aim to transform rapid response into a repeatable capability, not only for launch, but for all of our missions across cislunar space. In other words, we're just getting started. Go Firefly, go fly the lightning.
I like it. Go fly the lightning. And we are now less than 15 minutes away. The time just evaporates as we get this close in the count. Important things just happened while we were looking at that video. I think we're into the terminal. You know what it is.
Yeah, so we should be in what's called terminal count now. At about T-minus 15 minutes, we hand over control to our ground system.
Right.
So the operators that have been clicking buttons all day today, they basically are not going to click anything for the next 15 minutes.
They just run this. I say run the script,
yeah,
but
they run this auto sequence. The auto sequence is very complicated, and it's calling other auto sequences. It's performing actions. Right now, it's basically timed that 15 minutes on the engine chill. So you can see that little fog that's coming out of the bottom of the engines there.
Yeah, from the engine cam?
Yes, that is LOX that is blowing through these first stage LOX pumps. So we time this. It basically takes 15 minutes to chill in those pumps, so that's when terminal count starts.
Hey, by the way, on the engine cams real quick, when we were we have a lot of cameras for the broadcast, and we were choosing cameras, we saw the engine cam, we're like, we have to have the engine cam. And some folks were like, nobody wants the engine cam? No, that doesn't show much. Chat, do you want to see the engine cam? Let us know in the chat if you are interested in engine bell shots. There we go. Thank you. During rocket operations. So you can see the vapors there, like Miles said.
You can also see that flicker of it's kind of changing color. That's jumping liquid or gas. So as we're running through that line, that bleed line, there's heat going to that. So most of it is gas, but as it gets more and more chilled in, you'll see that it'll be more and more liquid.
It gets dark, like it's a darker white line, I guess, right?
Denser, yeah.
Yeah, denser. That's the right word. Nice. All right, so we're continuing to go forward here. 12 minutes and 40 seconds around that. What do we have coming up next? Some ground side preparations, I think.
Yeah, so we have the kind of last setting for TTEB and spin start. Both of those systems are kind of inherently dangerous to both the rocket and the pad. So we wait for a very long time before we do this.
Right.
We're single seat to the vehicle now. So we've opened up all the valves except for the last isolation that is going to be the thing that actually sends TTEP to the vehicle or
to light the engines
or does a spin start. Yes, to start the engines. We should, I think, here see also there's some TVC wiggles that are going to happen on the first stage engines.
We may not be able to catch them, but we'll see if we do. I saw them this morning.
Yeah, basically what that is, we bleed in a long time ago. We did some bleed ins, and then there's a last check in terminal count to verify that everything's hunky dory. That what they're doing is they're moving them, and they're not actually looking to just see that they move. They're seeing that they move smoothly, because the way that these TVC actuators work, they have something called a servo valve in them that if it ingests any gas, it'll kind of judder along.
It won't move smoothly.
Right. And that really affects your control system. You don't want to have that happening, so we need to make sure that we have a good bleed on the TVC.
Gotcha. So that's when they move back and forth. But we didn't mention the TVC on this rocket's really interesting. Sometimes the engines can wiggle, waggle, whatever term you want, in more than one direction. They can vector in more than one direction.
Right. So the Reaver engines only have a single axis thrust vector control.
They just move in one direction.
Each engine only has one axis. So you have pitch engines and yaw engines, which is kind of a common scheme in like Russian and Ukrainian rockets, but not so common in American rockets.
Okay.
But it's simpler. There's fewer parts. You don't have as many things to deal with. You don't have as many things that can break. Yep. So that's kind of typical Firefly direction.
Like each engine just hinges on one axis, and I imagine you have 4 engines. You probably have 2 pitch engines and 2 yaw engines?
Yep, and then they can all move together to roll the rocket.
Ah, gotcha. And they're probably at 90 degrees from each other, like the pitches and the yaws, and they makes sense. There's the engines again. I didn't see the TVC wiggle, but something you should probably check social if you're interested in TVC wiggles at some point. We'll see if we can get some of that out there for you. Coming up next is T-minus 10 minutes, just about 10 and a half right now. What do we have coming up after that?
So at T-minus 8, we're going to do the fuel pre-press. So for most of the day, there's been a small amount of blanket pressure on the fuel tank. Just to make it easier to control. We don't have to worry about ingesting water or anything into the tank. So there's a little bit of pressure.
Right.
We're going to go up all the way to flight pressure on that tank at T-minus 8 minutes. So that takes maybe 3 minutes to do that. So we do it fairly slowly just because we don't need to do it fast.
Why do you wait so long? Like, why don't you put it to full pressure before, earlier?
So and you'll kind of see this in all of these things, that there's a lot of stuff that's happening in these last 15 minutes, and it's all set up in time so that we don't put cycles on components that we don't want to cycle.
Ah.
So everything has some qualified number of cycles, and we want to make sure that we don't sort of erroneously put a cycle on something when we didn't need to, because if we're going to find a problem with something else that is, more critical, then we don't want to accidentally damage something.
Gotcha.
Out of that just by using it.
So every time you send it up to flight pressures, I guess, right? You use up one of those cycles.
Yeah, it's called a lolly.
A lolly?
Yeah.
What?
You're putting a lolly on the tank.
Putting a lolly on the tank. All right, burning one of the cycles that you have there, and you don't want to do that too many times. You want to make sure everything else is good to go before you put a lolly on.
Yeah,
I don't know how to use that as a verb.
That's how you do it. Before you put a lolly on the tank, you don't want to do that. So the fuel tank actually has it'll get pressed up first. The LOX tank doesn't get pressed up until T-minus 3 minutes. And part of that is that you can see where we're blowing that LOX out.
Yeah.
When we press that LOX tank up, you'll see this will pick up a lot. So you're going to be using more LOX through that bleed system, and you don't want to use too much LOX, so we wait until the very end.
Gotcha. And then after that, we're going to get into, after the fuel pre-press, I guess, begins. It takes some time to do that, right? We might get into stage 2, I think, huh?
Yeah, and I don't think we're going to be able to see this. I don't think we have a camera in the vehicle on this feed. We actually do have a camera in the vehicle that operators can see, and they're going to do the same thing as we did on the first stage, where we're going to look at the engine and see it move. It moves a lot less than the first stage engines because it's kind of
in the interstage.
It's in the interstage, so it doesn't have a lot of room.
So not visible from the outside of the rocket.
Yeah, but it'll do a little wiggle, and we'll just verify everything's good there, and just that's our last check of that system.
Gotcha. We got a big bunch of fog there all of a sudden, it looks like. All right, folks, we get this question a lot of the time, where you might be able to see today's launch from. We have a very interesting trajectory happening, but let's see in just a second if we can't give you a visibility map that shows where you might be able to see it. There we go. So there's Slick 2 over there at Vandenberg. That's the spreading T plus 30 seconds, 40 seconds. Down there in Los Angeles, you might look out over the ocean. Not sure if the clouds are going to be a problem out there for you. Up to San Francisco, you might be able to look south. Again, fighting the weather here. Not sure. If you can see it from Las Vegas, let us know on social media, please. Phoenix, good luck. But look out there today. If you're able to walk outside, you might get a chance to view the rocket heading out to its trajectory, carrying Flight 4, the Fly the Lightning mission, actually, for Lockheed Martin. Where are we at now? T-minus 7-ish minutes, I think? Yeah, there we go. Just crossed under T-minus. It actually says Stage 2 TVC wiggles on the screen. Nice. I like it. Also coming up here in 40 seconds or so, transitioning to internal power.
Right. So all day today, we've kept the batteries at charge, but we're not actually drawing power from the batteries on the vehicle. So we're just letting them sit there. They're doing their own thing, and we're feeding power to the vehicle from the ground. And that we're now switching over. We're switching over now to have the power draw from the vehicle and feed to directly.
So you're still like topping it off, but the vehicle is providing the power.
We're still keeping it charged because we don't want to have to
drain the battery
that is
carry more batteries.
To carry an extra 6 minutes of power, but
yeah. Makes sense. So moving to internal power is an important part of the step here that should be coming up in just a few seconds. We're going to see some visual motion here. After that, we'll get the collar arms open.
Yeah, at the top of the rocket on the strong back, you can see.
There you go. That's the view.
So those are going to open, and we keep them closed normally. Oh, there you go.
There you go. Good timing.
And then the strong back will retract a little bit after that once we're sure that the collar arms have done what they're supposed to do.
They are definitely retracting. It's almost like this is a carefully choreographed ballet of rocket machinery.
Almost. So those pull away. The strong back's going to retract. We don't do that early because the wind allowable on the rocket is much, much higher if you have that attached.
Ah, look at that. There it goes. And it's got a little slack in the umbilicals. The umbilicals, right?
Yep, those are umbilicals. We call them catenaries for some reason. Catenaries, the curve of when you're under gravity, and somehow that just stuck.
Well, they're curving a little bit less under gravity
industry
now.
term would be umbilicals.
All right.
You can see that there's these. It's getting away, but it's not actually. Nothing's tight yet. There is some maybe elastic pieces there.
Just a little, not droop to it.
Anything that's hard has a droop to it because the rocket is actually what pulls that off. The movement of the rocket will pull those QDs off.
Ah, so it's not something that pushes out or anything. Like the rocket starts to move and it pulls those QDs out.
There's a wire rope that's going to yank on those QDs and it'll open a latch and things will fall off.
Gotcha. Folks, it's 4 minutes and 30 seconds now. We're still marching towards the T0. I haven't seen any holds in the count or anything like that.
No.
We got that
Going good.
super smooth go, no-go poll. We do have one last go, no-go poll that's coming up here around T-minus 2 minutes. It may happen a little early. It may happen a little late. So if we're talking and we jump to that, we want to listen in on that final commit. But a lot of things still happening here. We saw the strongback retract. Look, this camera is even different now because the strongback has retracted. You can even see the ice on the side of it.
It's also, you can see it's one side that you get ice on.
Yep.
Because it's the same temperature, but there's just more airflow going over the other side.
I wonder if that's the windward side or the leeward side.
It's the leeward side.
It's the leeward side where the wind is not blowing.
Yep.
That freezes the ice. No kidding. And we're going to be getting into things like fuel bleed and that sort of stuff here, but now under 4 minutes from launch as we watch all sort of different views of the rockets. We do expect to have some pad audio coming up here as well. And for the last probably 90 seconds or so, we're just going to let you all soak in the sounds of the pad and hopefully the ignition and liftoff here. 3.5 minutes. Still counting down. This is go time, isn't it, Miles?
Yes. This is the nail biter.
How you doing? Can we put a heart rate monitor on you and like, graph it on the screen?
I'm climbing up the walls that I don't have plots in front of me.
Normally you have screens to look at, and here you don't have screens to look at.
It's hard.
All right. Well, the count continues to happen as we begin to cross over the T-minus 3 minute mark. Here again, this is Firefly's Flight 4. It is Fly the Lightning, a commercial mission for Lockheed Martin. About 1 minute away from that final commit to launch, where the launch conductor is going to ask for the go, no-go. So we are definitely going to listen in on that. We got some clouds up there today. I see a little bit of blue, but hopefully we get some visibility of the rocket as it goes. Can it go through the clouds?
Oh, yeah. There's a certain amount of thickness of clouds that you can't get through because of both ice buildup and tribo-electrification.
I was hoping we would get a chance to say that.
You'll charge the rocket up, which is bad for the avionics, but there's some amount of clouds you can get through, no trouble.
Good deal. So, folks, let's go ahead and do this. Let's listen in on the final commit. We'll do our best to be quiet.
Final commit for launch. Chief Engineer. Alpha is ready. Send it. Launch Director.
LD's go for Flight 4.
Rock. We are go for launch.
Folks, T-minus 2 minutes, that's what you wanted to hear. The final commit to launch. 3 goes from the Chief Engineer, the Launch Director, and the Range Operations Coordinator. Quick reminder for folks watching, we do expect that we'll have onboard video, hopefully, but we will be intentionally cutting that feed after SECO 1 at the request of the customer. We're coming up on 90 seconds, a minute and a half for Firefly's Flight 4.
Seconds.
You know something? I think we're going to listen into the pad and the command net, and we'll just say, go Alpha Flight 4, fly the Lightning.
T-minus 1 minute, 15 seconds away. Here's the venting from Alpha. Firefly. We're in terminal count. T-minus
60 seconds.
60 seconds, 1 minute away from Firefly, launching the Lockheed Martin ESA or whatever probe. If y'all paid attention, I know I didn't. But this is a Lockheed Martin probe.
45 seconds.
45 seconds. There's a good view of the engines, the engine bell cam. We should get some great view.
Acknowledging alarms.
They talk
30
way
seconds.
too. They talk way too.
CD1 vehicle has transitioned to autonomous mode.
20 seconds.
There's mission control before liftoff.
Stage 1 TVC motion looks nominal.
15.
15 seconds. Go from engine start.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Look at that! Oh my god! There's the engine exhaust. Coming out on Mach 1.
I see the clouds.
Vehicle supersonic.
Maximum aerodynamic pressure.
Vehicle supersonic now.
It's you.
So we're past max speed now as well.
Alright. Come up on some of our events. Miko, manager cutoff, stage separation, and lightning engine ignition. Ironically, it's named Fly the Lightning. So I guess
It's also great.
pretty
See the
sure-
plume start to expand there.
Okay, wait for stage separation. You can see the lightning engine.
That's the
right
lightning
there.
engine, isn't it, there?
Yep.
You should get Miko and stage separation at the same time. Oh, get ready. Pressurizing or depressurizing for stage separation.
That's Miko.
Miko manager
Miko.
cutoff.
Stage separation.
Look at that.
Lightning engine ignition.
Stage 2 ignition. Power looks nominal.
Yeah. Nice.
You can honestly see.
Seriously, see the booster there. The second stage continuing on.
Yeah, we
Yeah.
should see the fairings in just a second here.
Like they said, you could see the or the boosters. So that's cool. Fairing jettison. Ooh, my God. Woo!
That was
Separation.
the payload fairing. Separation.
Separation.
Just let them say it. Look at that view. Now this is a longer burn now, right?
Yeah, much longer.
The Reaver engines did their job, and now the Lightning engine is now propelling this payload into space. Great ground
Like the
station
Firefly logo there. Must be one of the long-range trackers, getting it through the clouds on occasion. It's easier to see through the clouds from up here.
Yeah, yes, it is. And we're going to start seeing, you can see a little bit, that second stage engine nozzle extension is going to start glowing, which is normal. That
Okay.
It's radiatively cooled because there's nothing around, right? It's vacuum.
Because of black body radiation coming off, it started to glow red.
And so you have to deliberately make sure that nozzle extension has high emissivity, so it'll cool itself naturally.
It'll radiate off a lot of that energy.
Mm-hmm.
Amazing views.
T plus 5 minutes. Everything is
The
nominal.
sun in the background there.
Alright. Amazing burn right there. can literally hear it. Kinda.
That'd be T plus 6 minutes.
T-Plex 6 minutes. That seems like we've been sitting here for like ages. Anyways, another thing, Booster 10 will conduct either an aerostack
Those onboard cameras keep sending us pixels. We'll take them.
or a spin prime or a crowd.
I think we should have it all the way through to Seco. It's pretty westward, so.
Yeah. And a quick reminder here, folks, at Seco 1, we do intentionally plan to cut the feeds from the vehicle at the request of the customer. We'll still be here with updates for you.
Coming up on Seco.
T plus 7 minutes.
In 1 minute, we'll get Seco, or 30 seconds, or anything. I would say about 1 minute till Seco. Come on Seco in about 30 seconds. And I will also
See a little piece of ice on occasion go past?
Mm-hmm.
in the stream.
Not all of it melts off. There's always a little bit.
And
Yeah.
cut my stream.
Stuck in little nooks and
I will not
crannies. And
If you watch the last video as well,
But
same
if
thing
I do
happened.
it to
Copy.
stay, then I will. Just take a good view of that before it goes away. That's the payload. See a solar array right there? That's Lockheed Martin, or Lockheed. I keep saying Lockheed Martin. It's Lockheed Martin.
Seco.
Seco, second engine, or Seco.
Nominal transfer orbit achieved.
there you have it. We got a transfer orbit achieved. It sounded like the call out there was.
That's pretty good.
That's pretty good.
Pretty happy about that.
That's pretty good, he says. Folks, you saw it. Flight 4 flew the Lightning. I guess we would say flew the Lightning.
Flew the Lightning.
We had liftoff from Vandenberg. Here's back at Texas. I think that second camera we have there, some clapping going on.
Expected LOS
But
at
let's talk about what's
in 10
next.
seconds.
I'm going to be quiet every time I hear mission control. We're still coasting. We've made it to Seco 1.
We're coasting.
Mission's not
so
done.
We're in orbit now. So we're in an elliptical orbit right now. And then if you think about kind of, we enter that at the lowest point in the orbit.
Right.
So now we have to coast along to the highest point in that
We're kind
orbit.
of coasting uphill right now, actually.
Yes. And so
Go to
once we get to
apogee.
that furthest point, then we'll light the engine again, and that'll circularize us. So then we'll be in
Circularize
a
it.
big circular orbit, and so that's the useful orbit.
Gotcha. So what
Then we're
happened
gonna
is we took a lot of
burn
chemical energy that was
to raise the
stored in the
curve.
fuel of the rocket. We turned that into kinetic energy, and we pushed the rocket forward, and now that's sort of coasting uphill, and it's turning it back into potential energy.
Yes.
Height above the surface of the Earth.
Physics lessons
It is.
in the live stream.
The velocity is decreasing now as it increases its altitude.
Yep.
And the total energy, it's a little bit of atmospheric drag maybe way up there, but the total energy is about the same. It's just trading height for speed right now.
Right. And so then at the top, that burn is super short. It's like I joke that it's a cough. Like
Puff.
it just, and it stops. So it comes up to power, drops almost instantly. It's like
It's just
a little triangle of thrust.
Just real quick.
And then we'll reorient the rocket, the stage with the RCS, so that we have these little nitrogen cold gas thrusters.
Right.
They're also active during the burns because you have to have roll control.
So keep it on its
because you only have one
trajectory.
engine, so there's nothing to keep you from spinning.
Ah, right.
And so those will reorient the stage, and then we'll deploy that payload, and then mission complete.
Good deal. So, folks, a reminder, the mission is still ongoing. We are in this coast phase, about 45 minutes long. We won't be on the entire time here. But for the most recent updates, make sure you head over to Firefly's social media channels. Over on X, there it is, at Firefly_space. And that is going to be the best, fastest way to get updates on the ongoing mission for Flight 04 here. Do it right now. If you do, let's get a clickable link into chat. Maybe in chat, tell us you went over there and followed Firefly_space on X. Now, that's not all for Firefly. What's Firefly got coming up next here?
Well, we got a lot more Alpha flights. Flight 5 is the NASA Venture Class Launch Services program. So
VCLS?
VCLS, yep. So we're launching a payload for them. That's happening in early 2024. It's also going to be a responsive launch, so it'll follow the same paradigm where we encapsulate and send the whole thing out to the pad and
minimize the time there.
Yeah, verticate, and leave.
He said it. It's a real word. Like you can use that in English class now.
I don't think
Scrabble.
I don't
You're
think
good.
it's a real word.
It counts in Scrabble. Point him to this webcast. That's a real word.
So we have we also have now our new orbital space tug Elytra. That is going to be flying on an Alpha. So it's kind of purpose designed to fly in Alphas. You could fly it on something else, but it's purpose designed for Alpha.
Oh, there you go.
That is for the NRO, and that is also responsive space operation. It's kind of different in that instead of it just being that we can launch whenever, we can now put up that OTV, that Elytra, and it's floating around, and you can command it to. It has a bunch of payloads on it, and then you say, okay, I want this one to go now, so it'll deploy something whenever.
Gotcha. Is that from Minecraft?
No,
not actually. As if I haven't asked him that question before.
Elytra are the on a Firefly or any Beetle. It's the like there are two sets of wings. It's the hard shell of the wings.
The hard shell of the wings.
Yeah.
Gotcha. So a scientific term there for that mission. Also coming up, Blue Ghost.
Yeah. So the first Blue Ghost mission is happening in 2024. We're flying to Mare Crisium, which is the if you look at the moon in the northern hemisphere, this is kind of hard to describe, but as it's rising, if you look at it, there's all these kind of black spots on it. Those are called Maria. The little spot in the top right corner is Mare Crisium. So we're landing on the edge of Mare Crisium.
Gotcha. And remember, if you're watching from Australia and looking at the moon's going to be upside down.
Yes.
A lot of people haven't thought of that. Like you're literally standing. Anyways.
That's part of NASA CLIPS. It's commercial lunar payload services. It's a bunch of instruments measuring radiation. There's some technology demonstrators on there, test sample collections. We're done with the structure of that, so we're now integrating that final lander to get sent up.
So not just renders, there's actual structure, there's hardware that's been built.
Yep. And then the second Blue Ghost mission is also in work. That's a little bit bigger.
Gotcha. All right. Other upcoming missions, folks. There's a lot of stuff going on with Firefly. Head over to their website, fireflyspace.com/missions. Mods, if you could put a clickable link into chat so folks can go and check that out. There's a ton of things that y'all are going on, including something we mentioned at the very beginning of the broadcast. MLV.
My rocket.
Your rocket.
Yeah. So MLV is our bigger rocket. We just had the first engine hot fire.
Now, wait, time out. That was green.
That was green.
Is that cool?
That's cool. That's TTEB. TTEB burns green. It's hard to see it green when on a video camera, but in stills it shows up green.
It shows up as green.
So we did that first Miranda engine hot fire. We have been building up like crazy. That's a picture of the AFP.
Like automated fiber?
Automated fiber placement machine. So what that does, it's basically like a 3D printer for composites, except that the benefit of this is that because you're laying down a single fiber at a time, you can put them in whatever direction you want.
You almost change the grain of the... It's not grain, really, but you know what I mean.
But it means that you can set those fibers to be in the direction that takes the most load, like optimally. So instead of 3D printing metal where you kind of have to add extra material and it is actually a little bit weaker, in AFP, you're making less material and it's stronger. So it's lighter weight and stronger. And also, it's easier to make. It's way faster.
And that's what you're using. I mean, that machine there was a picture of the machine there. That's going to be used on MLV, the medium launch vehicle.
Yes, it'll also be used on Alpha.
Okay.
So that'll switch us from building barrels in weeks to building barrels in days.
No kidding.
Which is pretty cool.
You have a lot of barrels out there, like a yard full of barrels?
We have got a lot of barrels out there. If you come and visit, it's Barrel City.
Barrel City. A lot of people don't understand it's not just about making one rocket, it's about making, like, learning the process to make the rocket.
Yes.
So you practice that. You have extra hardware sitting
honestly,
around,
the harder part is making a bunch of rockets.
Make some coffee tables or something out of it. I think the MLV is probably too big for a coffee table.
Yes.
Definitely. Folks, quick reminder, Flight 4 is still ongoing right now. If you want the latest updates on the status of Flight 4, make sure you head over to social at Firefly_space to get the latest updates. How are we doing on time here? We've been talking about a lot of different stuff. I don't really want to end the stream, but I know that we have a specific amount of time where we're supposed to end the stream. We're getting there, but not quite yet. Please make sure you follow along on Firefly Space. Now, you have on a cool shirt.
I do have on a cool shirt.
Don't try to show the back. We'll fall off the chair. We tried it in a hurry. We're like fall off the chair.
Yeah, I'll beef it.
So if you're interested in getting a mission patch for the launch that's happened today, or any of the other stuff that what else can they get?
Patches.
Patches.
And
there's patches. Wait, hang on. I got those.
Comically oversized guitar picks.
What is that? Hang on. That's a guitar pick?
Yeah, that's a guitar pick.
It looks like a miniature mission patch almost. I love the logo on this thing.
We usually make challenge coins, and we made these instead.
You made comically large. Have you ever ordered something from online and you're like, oh, that looks good, and then you get it and it's either way too big or way too small? This guitar pick is for a very large guitar. The mission patches as well. Also, I think there's like merch like T-shirts. Look at that. Fly the Lightning. If you don't have somebody to toss you a T-shirt behind the camera, head over to... That actually worked pretty well.
That did work
I'm surprised I caught that. Head over to fireflymerch.com. Let's see if we can't get the clickable link in the chat as well. Oh, geez. You know, we also... we were getting ready for the holiday spirit today. With our comically large guitar picks, we put together a little Christmas tree. Did we have we had a Christmas tree out on the pad. If y'all saw on social media this morning, there were some shots of a Christmas tree that was making the rounds around the pad while the red team was closing out things. There's a couple shots on social of a Christmas tree. I feel like I need to hold this thing up or anything. We taped guitar picks to the Christmas tree so that we could have it here to get into the holiday spirit. But folks, what'd you think of the launch today? You're watching over here. You could have had a couple different places you were watching that. Maybe you were over on social. Maybe you were watching on Firefly's official channel. Maybe you were watching on the NASA Spaceflight channel. We were providing live stream broadcast services for Firefly today. Let us know in the comments what you thought of the coverage, and let us know where you're watching from. One of the coolest things for me, Miles, is we get to share this sort of stuff with folks all over the world. It's not just people that are here able to, go to the Cape or to Vandenberg or wherever to see the launch. But by watching the live streams like this, y'all can be a part of this experience no matter where you are. So tell us in chat real quick. A lot of times I would try to speed read the names of places that they're from. But I don't have the capacity to do that right now. But just let us know where you were watching from all over the world. What else do we think is going on here? Miles is like good.
I'm pretty happy. I'm a little, anytime this happens, you're a little punch drunk for, the next couple of hours.
Yeah. Almost like rocket shell shocked a little bit, like adrenaline.
Yeah. We still need that second stage burn, the second burn, but
the mission is ongoing.
Yeah.
No declaration of celebration or anything like that.
No, not yet.
We've gotten a long way. We've gotten a lot of good data for sure from the mission that's been happening so far. But again, social media is going to be the right place to get those updates, Firefly_space, even after the stream ends here. So let's see. All right. I think that's going to bring us on to the end of the broadcast here. I think we were planning on having some relays. I do believe that we have pre-plays to show you here. Actually, that's why we were talking about where'd you watch from and stuff, because we needed just a minute more to get the relays better. Stall. We've got some angles that you didn't see on the live stream that we're going to share with you in these replays. Are they like playing music to play us off here? I'm not sure. They might be.
For the Oscars.
Hey, anyways, folks, thank you so much for joining us today. We put the tree on the ground, but happy holidays. Whichever way you were watching or however else you were sharing this experience with us, we do appreciate you. Make sure you follow the channels that you're on, especially Firefly's official channels over on YouTube. They're going to be continuing to release some cool stuff for you. Miles, appreciate the time today. Thank you so much for hanging out and watching the rocket launch.
Thanks for having me.
Providing a bunch of good information as well. I think there's a couple facts in there that I didn't know. And any stream where I learned something is a great stream. Also, folks, my name is John Galloway. I'm with NSF. You don't have to go home. Well, you should stay here and watch the replays because they're coming up next. Thank y'all so much for watching. Happy holidays, and we'll see you nerds later.
Ooh. There's a good view of the engine. Lift off. Ignition and liftoff again. Ooh, look at it. Look what it done to the camera. It shook it, but didn't fall off. Ignition. And liftoff. This is inside of the rocket with an ignition and liftoff. Go fly high, Firefly. That was a good. When I said that, I was like, I feel cool. Anyways, look at that! Oh my gosh, the good tracking skills. Firefly did it today. 2 successful missions in a row. And now bring their the success rate to about 75%. This is good. Ignition. And liftoff.